The second type of word problem that is going to require us to use rational equations is a working together. So we call this a working together type of word problem. So it could be for people working together. It could be for machines working together. So you have a large pump can empty a tank in 4 hours. A small pump takes 6 hours. How long would it take for the pumps working together to empty the tank? So we have, here's maybe, sounds like you have a tank full of water maybe, and one of the hoses is going, or one of the pumps, sorry, is going to take 4 hours to empty the whole thing. And then if you were to hook up the other one, this one would take 6 hours. And now we're going to turn them both on at the same time. So do you expect that it's going to take more time or less time? It should be a smaller amount of time because you're pumping out more if you're able to include both of the pumps. So the thing that it's asking us is what's going to help us figure out our variable. So what's the unknown? Yes, together. So X is the time it takes for both pumps to empty the tank. Okay, you can think about it like this. You have a situation where you're going to have one fraction of time. This could be pump 1. Or it could be, in a case, it could be person 1. Because 1 whole divided by the amount of time it takes, this is kind of similar to the distance and the rate situation, because you have one tank and it's being emptied at a rate of 4 hours is the rate. So it's going to be 1/4 of the way emptied. That's where you get the idea of 1/4. It's going to be 1/4 emptied after 1 hour. And then the other one could be 1 over B, and in this case it would be pump 2. It's going to have 1/6 of the tank emptied in 1 hour. And then if we add these two fractions together, we get 1 over X, and this is the amount of time it takes for them working together. So if we set up this equation, we have 1/4 plus 1/6 equals 1 over X, and we're going to solve that. Okay, and I actually have it there on the notes, but we're gonna do it by hand, so I'm crossing it out, covering it up. Okay, so what's the LCD? 12 and X, 12X. LCD here is 12X, and so if I multiply 12X here, 12X here, and 12X here, could we do the cross cancel? Okay, so this one becomes 3. So we have 3x times 1, right? And then this one, good, becomes 2x equals 12. Good. And so now what do we do to solve? Yes. So we get 5x equals 12, and then divide by 5 equals 12/5. Okay, which is what? Approximately what? 12/5. Yeah, it goes 2 and 2/5. So 2 and 2/5. So it's a little over 2 hours. 2 hours, getting close to a half, right? Almost a half. Not quite there. And if we divide that, we actually get 2.4 hours. Did you need that still? Sorry. This is the worked out problem, just as you see it, just exactly what I did. So so we would answer the question. Let's go back to the question then. Working together, the two tanks working together will take 2.4 hours. And by the way, that's not the same thing as 2 hours and 40 minutes, right? Because the 0.4, we could say 40% of an hour, whatever that is. And then we could also check this by plugging it back in, making sure it makes sense. Okay, any questions on that? The same thing. It's just in my handwriting. I think you should always try and check just to you want to also make sure that your answer seems reasonable. So that's why I was even asking you, do you expect the time to be less or more?